Why? Mm.
Because the different structure.
Because the condition is not good for humans amylase. Inside the detergent is very alkaline. Then you put inside washing machine, sometimes it's hot. You put like 30 degree, 40 degree, it's hot. That's why people use amylase, very strong amylase from bacteria. Then you can also, people also mutate the amylase. So it becomes stronger and it can be resistant to heat and high pH. That's why we want to know the structure, we do the modeling, because we can engineer the enzyme, improve the enzyme. So this is the second answer for your question. Amylase, protein engineering. So why we want to do modeling is
Function, protein engineering.
function and then protein engineering. Can you think of the third reason? Another reason why we want to know the modeling.
Why make the modeling?
Yes, why you want to make model.
Okay.
The easier example, COVID.
Mm-hmm.
Yeah, I told you before, right? COVID, so many proteins. One of the protein is the protease, the anthro protease. Do you know what is a protease? Maybe I type, then you can understand. Protease.
Protease enzyme.
Yeah, protease is an enzyme. Hello. You know protease? Protease is an enzyme that cleave protein, cleave other protein, integrate other proteins. You see, amylase degrade sugar. Okay, glucose, starch, they are sugar. Amylase degrades sugar, protease degrades protein. Do you know what is the enzyme that degrades DNA? DNase.
Yeah,
You know what DNase? Okay, so there are enzymes that can degrade.
Deanase. I'm using deanase blocking the DNA. I need only, in my work, need only the protein.
Protein.
Yeah. Some found in my sample found the DNA. I use deanase blocking the DNA.
Yeah, yes.
Yeah.
Yes, you want to purify it, you remove DNA,
Yeah,
use
I told
DNase,
it,
RNase, yes, to prepare a sample, right?
Yeah.
Sometimes, yes, we have the DNA, RNase, why got free water? RNase, so DNase, RNase, they are nucleases.
Deanase.
DNase, RNase, they are nuclease. Enzyme that cleave DNA and RNA. Protease is enzyme that cleave proteins. Okay, so COVID has a long polymers. Long. The COVID protein is very long. It's like 12 protein together. Then they need the protease to cleave the protein into individual proteins. You know the COVID genome much. Oh, maybe I talk too much already. This is just for you to know lah. Yes. You know what? The SARS-CoV, it has one RNA. And then the RNA, it code a long polyprotein. And all this protein will be cleaved by protease into one individual protein. One of the protein is this one. What is this? This is the protease. So why do we want to know the structure? The third reason is, how do you want to cure COVID?
You detect the mutation in the structure?
That is also one reason.
Yeah.
You want to look at the mutation.
Yeah.
There's another reason why we study COVID. Because it is interesting.
Yeah, yeah. I need to detect the receptor for infection. Yeah.
So-
How can make the mechanism for the infection? I need to detect the mechanism for the protein and the lysis and the something. You detect the seed infection causes the disease. I think difficult.
It's not difficult. I mean, like why? You know, protein, key and log. Have you heard of this one? Key and log.
Mm-hmm.
The protein enzyme for enzyme is something like this one. Like enzyme is always like this. You have a substrate. Then one enzyme can only cleave. One enzyme can only normally can only cleave one type of substrate because you see the shape is very compatible. Okay, so this is what we call a key and log. Then, do you know why we study COVID? Why? Can you tell me why we study COVID? We study COVID because, is it because COVID is interesting? COVID is dangerous, right? It was dangerous. So we study it in order to kill it, right? To kill COVID. How?
What?
Study structure.
How do you kill COVID? You can boil it, right?
Yeah, study structure,
Oh,
study the infection, study effective, study enzyme for COVID.
I'm not.
Then how to kill it? You cannot just catch the COVID and boil it. If the COVID is inside your body,
You
are
can
you
make
going-
lysis.
Hmm?
Lysis, some lysis affect the COVID.
Lysis?
Yeah.
So we study COVID because we want to kill it. And how do you kill COVID? One way is boil, but you cannot boil yourself. If the COVID is inside your body already, are you going to boil yourself?
Then we can see. So yeah. So design a vacancy.
So how do we kill COVID? Like just now I don't understand what you say. Maybe you can say again. Lice?
Lice, yeah. You
Lice.
can make the lice. Same the injection, same the drug.
Yes.
Yeah.
Drug.
Yeah,
You want to
Lice.
design drug.
yeah.
Drug.
Yeah.
Drug.
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 Yeah.
Yeah.
Okay, I'll just type up so for you to understand properly lah. Drug.
Understand, but
Medicine.
difficult for English.
No, simple word. Medicine.
Yeah.
How to design medicine?
Use the tool for bioinformatics,
Yes, you need to know the shape. You need to know.
structure and function.
You need to know this shape. Then you can design something, a drug that can bind to this shape. That's why you need to know modeling.
Yeah.
Once you know the modeling, you can design a drug that can fit the active site.
Dynamic the shape.
Determine the shape.
Yeah.
Yes. So 3 reasons. When you study the structure, we do the model first.
Function.
Based on the shape of the active site, we can guess its function.
Yeah.
The function, okay?
Yeah.
Then you can mutate the active site to improve its activity.
Protein engineering.
Yes, protein engineering, the second reason. And the third reason, if this is a pathogens enzyme,
Drive.
yes, you can design drug. Or even humans, protein, we also can, let's say this is a receptor for pain. You can design painkiller. Okay, you can design painkiller to
This 3 point function.
oh,
Protein engineer. Drug.
drug design.
Yeah.
This is the reason why we want to do modeling of why we do modeling. If we can solve the structure using NMR or X-ray crystallography, then of course that's better. But there are so many proteins. Sometimes the proteins are very similar to known proteins. Then you just do the modeling. Okay? This is the reason.
What is painkiller?
Painkiller?
Yeah.
Painkiller is, let's say this is the receptor for pain on your body,
Yeah.
human protein. So we can design a drug that can bind to it. Then you won't feel painful. Painkiller is a big market. Everyone will get painful someday, especially when you are sick or when you are old. So if, let's say after you study this, and then you go back, you design one painkiller, and if that painkiller is good, you will become billionaire. You sell your painkiller, you become rich. Then I will go and work for you. You become my boss. Okay? There are many things. And let's say this is the receptor for glucose, sweets. Okay? In our tongue, we have receptor. It can detect glucose. So when you eat glucose, very sweet, nice, chocolate lah, ice cream. But when you eat glucose too much, you will get diabetics. You will get fat. So people try to design artificial sugar. Sugar that can bind to the receptor. But the sugar cannot be a salt. So you can put a lot, still sweet, but you won't become diabetic, you won't become fat. If you can design artificial sugar. So it's the same way lah. Either you design drugs, or you design artificial sugars, artificial things that people can eat and it's still not harmful, you will become rich. We study because we want to be rich, right? Yeah. If you become a lecturer, you will not become rich. Okay.
No, this. But some I'm studying because need some development, English development or something. Yeah.
Very sleepy, huh? After lunch, we should do this in the morning, huh? Not after lunch. Huh?
Yeah.
After lunch is too tiring. We are sleepy. I also sleepy. Okay, come. You want me to go through the questions?
Yeah, already write the question and write this section.
The question, the exam questions?
Yeah. Why need make the modeling for protein?
This you know already, right?
Yeah.
You can understand now.
Yeah. I share this after this. I share with the girl.
So 去日本 yeah.
Okay. I'm write this English share with the girl. This is question.
You can sell him
Okay.
100 ringgit.
Yeah.
It's cheap, not expensive.
Yeah.
Okay.
Yeah.
So now what do you want me to go through?
Structure.
You want to know the questions for the exam? You want to go through the questions? This is the exam, right?
Yeah.
Alright, okay. 1, 2, 3.
I think this question we need only 2 because I have 6 questions.
6 questions, but only 2, yes, 2 of 3 questions in B.
Yeah.
So in section B, you can choose not
choose
question.
choose for you.
Why you want to choose my question?
This is easy. I'm reading. I'm giving some information for
You
you.
mean this is easier?
No, this is difficult. This is easy. This is easy.
Either than the others, yeah.
But this one I don't know. I'm not sure it will come out or not.
What? No, Victor.
I cannot tell you what the questions are. I
No,
cannot.
tell tell only the important question.
Important questions, a lot of questions. I guess you can answer 3 and 4 easier.
No.
3 and 4 also difficult.
Yeah.
So mine is easier.
For you, no, need more writing, more something. Please, doctor, need help. I need go my country after exam.
Yeah,
So okay. Okay, so this A, the question A actually is more biochemistry lah. It's like how enzyme functions lah. This one, okay, I just quickly go through the answer. Oh yeah, this one this is the style how enzyme functions. One.
All protein binding, it's one hormone. Yes.
Okay lah, I don't want to confuse you more lah because wow, it's already normal. So okay, the number A, this question is not coming out lah. So we skip it lah. We don't need to learn A lah because for this time,
Please, doctor, don't have time. I don't have with the girl. Don't have time because 4 days need.
so this time my question I only have A and B, no more A B C,
Mhm.
only A and B.
Yeah.
Okay, and then B,
D.
no B. So for B,
Yeah.
okay, the B, can you understand the question?
B.
B.
In the glucose 6
Okay.
phosphate, the
Uh-huh.
hydrogen G6PD, the seed chain of the 2395 for the hydrogenic binding with the phosphate group of the glucose phosphate lysis effect mutagen. This all.
Okay. You know, okay, you translate already, yeah? You understand, Okay. You know glutamine? The structure of glutamine is already here, right? Glutamine.
Mm-hmm.
And then GLU is glutamic acid.
Mm-hmm.
Do you know the difference? Glutamine and glutamic acid. You see, I already give you the structure. Glutamine and glutamic acid.
Have 2O and have.
Okay, can you see? What's the difference? One is
But
this.
for your question, not need different.
Hmm?
But for any question, not need different between this.
The difference. So I mean, the question is, we have a glutamine.
Yeah.
The glutamine is mutated to glutamic acid.
Mm-hmm.
So what become what? This become this.
Mm-hmm.
Okay, what change? Inside this, what become what in this? Okay, can you see the difference?
Mm-hmm.
What is the difference? Here is
This have carbon, CO,
Mhm.
هنا CO double OH, NaS2, NH2, not find NH2.
okay. So actually this is something like this lah. You can see here. This is aspartate and aspartate. Actually this is aspartic acid lah. Aspartic acid and asparagine. Glutamic acid and glutamine is something like this one. You see the first is what? CO and then NH2, right? This is in the slide you already have, right? Last year. The only difference is here. You see NH2 become O.
Yeah.
That's the
This
only
have
difference.
oxygen or
The CO still there, CO. This is aspartic acid. The question is glutamic acid. Glutamic acid, the only difference is you have one extra CH2. CH2, this. That is glutamic acid. Just the difference, one extra CH2, longer. But here is still the same. Okay. So actually that one, even that one I already give you the asparagine and glutamine. Mhm. Okay, this one asparagine, aspartic acid, glutamic acid. So what's the difference is this is the backbone. So this is the fat chain. You can see asparagine is only one C, but glutamine is 2C. 2C, then this is exactly the same. ONH2. Then
You have NHA2.
ONH2, ONH2. This is the same. Glutamine and asparagine is just only one C here,
Yeah.
but 2C here.
Yeah.
Okay, that's the difference. And then asparagine is ONH2, aspartic acid is OOH. That's the difference. So the question is, inside the G6PD, we have the glutamine. This one. We have glutamine, this. Glutamine is mutated to glutamic acid. So the difference is this one becomes this one. So what are the effects of this mutation? What will happen? Will it affect the enzyme's activity or not? Okay. Now we go back to the slide. This. So you know now the question is this one become this one. Okay. What is the difference between these two?
Because different NS2,
You have NH2.
only O.
NH2. So this group can do what with the ligands? I mean like this group has what that this group does not have.
It's a mutation.
Yeah. This is mutated to this.
Yeah.
So in native form, you have this one. So when you have this, what do you have here? What can do? What can this group do? And this group has what? What you don't have here? You have H.
Doctor means the effect is the difference is same. The same difference of the
Here
between
we
the
have H.
base.
How? Okay. Wow.
Translate.
You translate or what translate? You translate.
Translate this question.
Okay, now see how protein. This is a protein. This is a ligand. Okay, how protein binds the ligand? How? You look here. Hydrogen bonds and electrostatic interactions. Okay. Electrostatic is, you can see
About bond, hydrogen bond.
plus and minus. No?
Yeah.
Then hydrogen bond is this one. You need a H. H to bind to the O.
O.
Hydrogen bond. Okay. HO. Sometimes here we have the H. This O can be. So this one is hydrogen bond. This is donor. This is receptor.
Yeah.
Okay. This one, it donates the H for hydrogen bond. This one accept the H. Alright? So we have basically two types of interaction. Hydrogen bond and electrostatic attraction. Electrostatic, okay, so now glutamic acid. Glutamic acid also can form hydrogen bonds, right? Okay. Now, can you tell me this and this? What's the difference? They also form. These also form hydrogen bonds. This serine also form hydrogen bonds.
This have 4 bond. This have 1 bond.
No, we will just look at this bond.
Mhm.
So
What?
what is the difference between this and this? So,
Why we not compare with the
Yeah,
engineer and
I just want to compare this O.
This is honor.
Yes, this one has the H,
Yeah.
so it can bind to this hydrogen bond. This one doesn't have any H, no H,
Mhm.
so it can bind this
You
one.
can buy H with other honor.
If this O does not have H, can it form hydrogen bonds with this one?
I know.
Okay. If this O does not, if we take away this H, can this O still form hydrogen bonds with this? How come? Can? This one is O, it does not have H.
Yeah.
Ah,
But
if
already
you-
bind with the
Can you understand? If you remove this H,
Mhm.
do you still have the hydrogen bond between this O and O? Now, the hydrogen bond between these two O is because we have a H. OHO. Alright?
Mhm.
If you remove this H,
Mhm.
if you remove this H, you only have OO. Can you form hydrogen bonds?
No.
Yeah, you cannot already.
No, already removed.
So you can see the mutation there just now.
The mutation remove the hydrogen.
You see? Oops. So we also need to see how it interacts. When we form hydrogen bonds, when we say this form hydrogen bond, is it donating the hydrogen bond or accepting the hydrogen bond? Okay?
During the mutation, the hydrogen bond donator, the other.
The serine is good. Here. This is another serine. This is best. This O, it can donate hydrogen bonds.
Yeah.
At the same time, it can also accept hydrogen bonds. Alright? So if, let's say this one, we take away the H, these hydrogen bonds disappear, no more.
Mhm.
But you still can have this hydrogen bond. Alright?
Right.
Okay. Then you go back to the question.
During the answer the question, you can draw the
You can draw anything if
make the draw why the make the mutation, the donor, the OH. Yeah, you can draw this during the.
if you want to
answer.
draw, yes, can.
This good.
You draw, yes.
Uh-huh.
If it is correct, I will give you mark.
Thank you.
Okay. So now, maybe the question is a little bit tricky lah. The question is, can you show me the question again? It says that forms a hydrogen bond. Yeah, I should put donate a hydrogen bond.
Yeah, see.
Donate a hydrogen bond, it will be easier. Okay, so now there are two things. So this can donate hydrogen bonds, right? But this one cannot donate hydrogen bond. It can only accept.
Why?
Alright?
Because we have two.
No, because it does not have H.
Oh.
You don't have H, it cannot donate hydrogen bond. You can only accept H. You cannot share your H.
Oxygen need hydrogen. O need H. The H not donor, the O not donor.
but by accepting the H and we still
It still can form hydrogen
Yeah,
bonds,
yeah.
but it can only accept, it cannot donate.
Yeah, I know. Yes.
So the question,
so it have some effects. It has some effect. Yeah, just can accept, not show, not share.
okay, because the question, well,
I mean, I just think the sharing or and the accepting is same hydrogen.
yes, but you see the question, it binds to what? Phosphate group of glucose, okay?
For escape group.
Phosphate phosphate group of glucose. Okay, now come, I show you.
Phosphate.
Maybe I need to be G6P. You know G6P?
Yeah.
This is G6P. This is G6P. Okay.
Yeah.
Glucose 6-phosphate. 6 is because number are 1, 2, 3, 4, 5, 6. And the 6th place you have C6. This is C. C6 you have the phosphate. Alright. So just now we don't care this is histidine, but let's say now you have NH. It can form hydrogen bonds with this, right? If you do not have H, can it still form hydrogen bonds or not? Because phosphate
Don't. Oh yeah.
phosphate no H.
Don't have hydrogen.
It doesn't have H. There's no H. So when you mutate this O, there's no more H. So one thing is no more hydrogen bonds. Alright? Come. You can ask.
Wait. Really? And combine with one? Yeah. Oh, wait.
No, this is the example. You can, I'll show you this.
For the slide.
Yeah. I just want to know why we come to combine with C6. Yeah. What stage is it? This belong to
This H.
It's all belong.
So for H,
Yeah.
actually all here we also have H, but they don't show it. This H is important for catalysis. So that's why they show you how the H is taken away. How the H is taken away. Like they form this way, G6PD, G6PD. This is the mechanism, but we are not talking here, we are talking about this one. This is for recognition. So we need to see the G6PD. What is the mechanism for G6PD? Actually, G6PD it G6PD is this one. G6PD will remove this hydrogen and become this one. So just now the reaction is, you see, take away the hydrogen and to form this one. This is the G6PD. But we are talking about the phosphates here. We're talking about the phosphate. Just now you are looking at another histidine interacting with this one in order to form this. The phosphoglucanolactone. Okay. So this one is too complicated, so I'm not asking any question here. Alright. Okay, now come. I show you this. This one. This is better. Okay. So just now you are asking me about this H, right? We are talking about this H. In the enzyme, inside the enzyme, there are several residues. It can bind here, can bind here, can bind here, and then can interact with here as well. So if you go back, you look at this one, G6PD. Just now, the histidine that we are talking about is this histidine. This histidine, here we have the H. It's not shown here. This is the catalytic histidine. Then we'll make this one, you have another H. So you will remove the H and then this one become double bonds with the O. This is here. Now what I'm talking about is just now the glutamic acid is here. It is forming a hydrogen bond here. Actually this figure is not good. This is no hydrogen bond. Because this one no H. This one no H, this one also no H, so it cannot form the hydrogen bond. I have to remove this bond. So there's only one hydrogen bond. This is glutamine. Okay.
One hydrogen bond, glutamine.
Glutamine, it has the NH2. So it can form one hydrogen bond. Actually, it has another H. NH2, 2H, right? So one hydrogen bond, it still have another H, is free. The H can maybe bind another water. Okay? So now, the question is, this, when you mutate to glutamic acid, this become O. So can it still form hydrogen bond? Can or not?
Yeah, this last one have the hydrogen bond. First one not have.
Do you understand now?
Yeah.
So this, let's say this is glutamine. Let's say you think this is glutamine. Okay, the glutamine has the NH. NH actually is NH2 lah. You don't look at the NH lah. Okay, so the NH is forming a hydrogen bond with phosphate. Okay, so when this NH become O, there's no more H, right? This is O. If this is O, no more H. Do you think it still can form hydrogen bonds or not? Can or not?
You can.
If this is O,
Yeah.
can O.
Can.
Cannot. Can or cannot?
Can.
Where?
Because we have hydrogen.
Okay, you remember this one? NH forming
Yeah.
hydrogen bond with the phosphate, okay? You're hungry.
No.
Victor, this is solution for the question?
No, this is not. I want to talk. Just now the NH form a hydrogen bond with phosphate. Okay? NH form a hydrogen bond with phosphate. Now become this COO. Can the COO still form hydrogen bond with phosphate? Can or not?
No.
Huh?
No.
Why?
Because do not have H.
Yes. No more H, right?
Yeah.
The H disappeared, so there they cannot form hydrogen bond. So the question, now you know the answer for B.
Yeah.
So the answer asks you the effect of mutating glutamine, mutating this to this. Okay? Alright? So you know already the answer? Because the question already say, actually it already tell you the glutamine when it's this one glutamine, it form a hydrogen bond with the phosphate, right? Forms a hydrogen bond with a phosphate. The hydrogen bond is already a key word. So when this NH2 is mutated to become, well, actually I put COOH lah. Actually, this is COOH.
Yes, also have H.
Also have H, but we have to think in our body, the pH is, you know pH, COOH, actually there's another H. It has a H. But the glutamic acid as well as aspartic acid in our body, it is usually deprotonated. Okay, because it is acid, the H always go up.
It's inico.
Because our body pH is 7, around 7. You have to look at the PI. Do you know the PI? You know PI, right?
Yeah, I know. I like this.
Oh yeah, ionic. Yeah, it's ionic.
Ionic, yes.
Yeah.
You know PI, glutamic acid, maybe lah. In that sense, maybe it's a bit difficult lah. Glycine, glutamic acid, the side chain not PI lah, it's PKA. What we say is PKA. You can see glutamic acid. Glutamic acid. This is PKA1, PKA2 is the main chain.
Yeah.
We look at this one. Glutamic acid, aspartic acid is 4.25. 4.25 is the pKa for the side chain. So when the pH is 7, it means it is deprotonated, it is ionic, it is COO minus. Okay, come. So do you know how to answer this question already?
Okay, wait, I show you this.
Just one reason.
Huh?
Just one question.
No, no.
It's okay.
No, I mean this question.
Oh yeah.
For this question, do you know how to answer already?
I mean this question for this question just one the
Answer.
Yeah, just one.
No. So this is the first part of the question.
Yeah.
The first part of the answer. Okay, for
So,
this question,
yeah.
we've not finished yet. We only finished half.
What?
So first is the
Huh?
hydrogen bomb disappear already, right?
Yeah.
So it cannot form hydrogen bomb.
Yeah.
Okay, second is very simple.
Yeah.
So second, can you guess the second? The answer for this question?
Yeah.
There's another part. Now it
Because
is
this correct solution?
Solution.
who give you this one? Or you type yourself?
Yeah. I write this because
Negatively charged one.
Is your answer?
I might make the solution other time. This for
one
me.
who give you this?
This for me. I'm searching internet.
You search internet.
Yeah.
Mm.
This good or not?
Okay, the second question, the second part is already inside this answer. So now you know this is what?
Yeah.
Yeah, it's what?
Yeah.
So you know the answer already? Then I'm not telling you, huh?
Okay. Continue.
He knows already, he showed me the answer.
Yeah.
His answer is, so this is what?
This is
电荷
this is
怎么
one.
说呢？
This is what? This sign is? This sign is what?
This point, the
You show me this one, but you still cannot tell me this is what?
I can't write.
No, you don't read this one. I guess definitely this is not written by you. The English is so good. I know it's not you.
No, this by internet, not for me.
Yeah, internet.
Yeah.
So now, without looking at this one, what is this? I mean,
This
Navigative
I'll give you back.
electric.
Okay.
Huh?
Navigative
This
electric.
This is what?
Mobile?
No, this is
Mutation.
mutation, but what does this mean?
G6PD?
This
Charge.
dash is
What is charge?
That's for
this you don't find here.
yeah.
This thing you don't. This one you don't have here.
Mm-hmm.
You have here. And what is this?
Because not have oxygen, not have H.
What is this?
Navigative charge. I don't know why it charges.
It's negative charge because you don't have H already. COO minus, right?
Yeah.
So it's negative. So this group is negatively charged. It's negatively charged. This is neutral. In the sense, it's neutral. Or you can say it's polar. But basically, it's neutral. It does not have any charge.
Yeah.
So, do you think what will happen? This is negatively charged. What will happen?
Because do not have H.
Last picture.
Okay, we come back
Yeah.
here.
Yeah.
Okay, you just look at this phosphate. What do you see? You also have this thing.
2 minus.
Minus charge.
Yeah.
So what do you think?
Because the
What
donor
will
2
happen?
oxygen, donor 2 H.
So this one, this is the phosphate. Okay,
Yeah.
just not the same. 2 minus charge. So this is negative. And then if this mutate to glutamic acid, it become negative again. What will happen?
Because don't the donor the H, not find the H, the place for H negative.
So now we don't have hydrogen bond already.
Yeah.
At the same time, it become negative. Right? Negative and negative, what happened?
Positive. Yeah.
This is negative, this is negative.
Yeah.
And then this also become negative. What will happen?
Donor 2 H. Donor 2 H. Donor 2 H not find. You understand? Me? take two hydrogen,
Charge bond.
two hydrogens.
So now
The
this,
place,
so this become, now this is glutamine, right?
Mhm.
If it is mutated to glutamic acid, it become negative. Okay, now this is negative. This is also negative. What will happen? If this is mutated
lose
to
two
glutamic acid,
hydrogen, because lose two hydrogen.
then what will happen? If this one become glutamic acid, it become negative. This also negative. So what will happen?
Mutation?
Yeah, after the mutation, what will happen? If it is glutamic acid now, it is negative and this is negative, what will happen? Negative and negative, yeah?
Positive? Negative and negative?
Do you have magnet? You have N and S. So now you have a negative. You also have a negative. Will they come together?
Yeah. Not active.
The same charge will
Yeah.
是
You just Google and see what do you call ch. You have negative and negative, what will happen?
相似 What's this? Like, pulse, repel.
Repel, right?
Repel.
REPL, right?
Yeah.
REPL. Yeah, they will repel. They will move away.
Just same the magnetic.
Negative and negative. If negative and
Some-
positive, they will
Same the
attract.
magnetic. Negative, positive, touch.
Mm.
Positive, not touch. Negative,
Positive,
negative.
negative and negative, they will repel.
Yeah.
So if
Same the activation for magnetic.
So this glucose, when it come in, when this come in, this is negative. You come in and you have to go out. You go out, it cannot fix, cannot go inside because this is negative already. You will repel in. So most likely this will go out. This substrate cannot bind. Okay, so now you understand.
Yeah.
So sometimes this is just to let you know, sometimes one mutation can change a lot. This mutation is not only, this mutation is so small. This mutation is just change the NH2, you just change to O. And totally different already.
Not the H2, it's NH. Yeah. NH positive.
NH2 become O. Actually, it's become OH lah.
But this H is sharing when
The O, the NH2,
Yeah,
the H. The H is sharing with the phosphate lah.
So it's
The phosphate is
NH
uh,
H positive chain.
this one NH. You have the H. H is not shown here, but you know the H because they form a hydrogen bond. So the H is here. The H is in the middle. It's here lah. H. This one there's no bond here. This bond is wrong. I have to remove this bond. Okay. Now you can understand. This is because the glutamic acid is inside the active site. Let's say this is the this is the enzyme. So this is the active site. So glutamine, we have the glutamine become a glutamate here. If let's say there's another glutamine on the surface, another glutamine on the surface of the protein, okay, and it is mutated to glutamic acid, the same. What will happen?
The mutation effect.
Now let's say I can draw here.
Yeah, come.
Okay, now let's say this is the enzyme. Okay, now just now is the G6P lah. This is the active site. Glutamine. You have this is glutamic acid and then this is glutamine. Glutamic acid is E. Glutamine is Q. Okay. You understand? Let's say just now the answer the question is now here you have the Q. Q become E. And then we have the phosphate lah, the G6P lah, G6P. This is the substrate. This is glutamine, become glutamic acid, and it cannot bind already, right? Okay, let's say now you have another one, another Q here, but it is also mutated to E. What do you think will happen? Will this affect the enzyme or not?
Effect.
Now this is the enzyme, okay, enzyme.
Yeah.
This is the active site,
Yeah.
Active site you have the Q. Q is mutated to E. Then just now we see, okay, it cannot bind. E cannot form hydrogen bond, and E is minus, negative, minus, so it will repel this. So most likely it cannot interact already lah. So consider with another Q on the surface of the enzyme, and this Q is also mutated to E.
Now the enzyme have two mutations.
Let's say lah, there are two mutations.
Yeah.
So
Already affect the enzyme because the two mutation change the.
this first mutation,
Yeah.
okay, it will affect, right? It will affect.
Yeah.
Second mutation, do you think this second mutation will affect or not?
Effect.
Why?
Why? Because the change the QE. Now the effect two placed for enzyme.
Do you think it will affect or not?
Effect.
This is very far away from the active site. This is inside the active site. Now the first question is this and this, huh? You can see here. Wow, this really affects. But let's say if we have another one is on the surface, it's very far away from the active site. Do you think it will still affect? It will affect G6P or not? It will affect the binding of this or not? It's so far away.
This effect.
This will affect, number one will affect, number two, what about number two?
Number two, I think now after the understand not effect because outside.
Yes, it's too far away.
Yeah.
It's far away from the active site. So most likely.
This location though for active site and
yes,
enzyme.
active site.
You can make the mutation in this area. You can affect far because this active site, this out active site, the mutation not affect because the out.
So it's not affecting.
Yeah.
So most likely it will not affect.
Not affect.
That's why when we do modeling, we see the mutation. We also need to know where the mutation is. If the mutation is inside the active site, we have to see how it interact. If it's outside, it's far away, maybe it's not important. So we can say, yeah, it's outside, so maybe it's not important, it's not affecting. That's why we want to do modeling. When we do modeling, now you know already how to do modeling. But what happened? After modeling, next, you need to analyze the mutations. You need to analyze the structure. That's why the question is to teach you how to analyze. So now you know maybe in my lecture I did not talk too much because I assume it's straightforward, so I thought you people would know Okay, I can give you back your.
This correct solution? This correct or not correct? For your question?
I already told you the answer.
Yeah, I know.
So you can read and then you can judge already whether this is correct or not. Right? I already told you the answer. Okay. So now you know when the mutation is far away, maybe it's not important.
For answer, you can ask me. You have two mutation. The one mutation inside. Inside.
I don't know. I don't know the question. The exam question. I don't know. Now I told you these two is like let's say you have two similar mutation. Also Q become E. Then you have to see where it is.
The one mutation inside activity.
Inside activity, and this one is already interact with phosphate. So you know
Yeah.
But if it's far away, it's not interacting with anything.
Because
so
it's very far.
Maybe it's not important.
Question?
Oh, it's the pen now. Oh, another question.
Where I can find I can find the
The what?
what the inside or the outside.
You don't have to worry.
No,
I will
this
tell you.
question.
This one, this question I just asked for one mutation. This is only one mutation. This question is I just asked you extra question. So I will tell you. I mean the question will tell you the mutation
so-
where it is. You don't have to.
This structure is
Yeah, because it tells you forms a hydrogen bond with the phosphate.
yeah.
Yeah, you
So-
can draw. Or I'm the
It's bound in the
solution only draw.
inside of
Yes.
the
Because it's formed with the phosphate. So where do you think it is?
say so this
So this must be inside the active site.
yeah. This must be inside. Okay.
Right? If it's outside far away, how can it form?
What
How can
effect?
it interact?
Outside, not
That-
effect.
uh,
Inside effects.
This
Then this is on the surface of the protein. It's not inside the active site. Okay. So like that's why when you have mutation, we need to know lah how the mutation will affect the activity of the enzyme.
so this sentence indicates the site of
This is the
Yeah.
active site.
Yeah.
That's why
Then-
form a hydrogen bond. Right?
Okay.
Okay. All right. And
This
the
bond
C
must forming the side one. Okay, I see.
here.
Yeah.
So it's easy, right?
Yeah,
It's
easy.
not that difficult, right?
Yeah. Now it's easy.
But the detail is complicated.
It's not that complicated after you understand it.
Yeah.
All right.
Alright.
Okay, last question. C. C is very straightforward. Okay.
It's for COVID.
So this exactly is similar to B lah. It just tell you so we have a new COVID. Okay, and then the protease M pro. Now you have a new COVID. So it has a new protease M protease. There are some mutation already lah, most likely. So what can you do using modeling?
Modeling,
I mean like
structure and
okay, design the step to characterize the mutant M pro.
yeah.
So by using the many known structures of native M pro complexes.
This question not important.
This one actually is very simple lah. So design the steps to characterize 3 marks. Design the steps to characterize it.
Please, doctor, don't have time reading more because too much lectures.
I don't know.
This
So-
is a question important with this question.
So this one, number 1, design the steps. It's very easy. How?
This is important.
Hmm?
This is important.
Number 1.
Easy but hard.
Huh?
Number 1 important.
Let's say next year lah. Next year you have a new COVID.
No. Now the books, monkey books.
Yes,
Yeah.
the new one, different.
Now in America and or you need buy the drug. You need buy drug. How can buy drug? You need make the a new disease. Yeah,
Even mutate.
found in the lab biological in the some country. This country do not have oil, do not have the company, do not have only company for drug.
Still can make money.
yeah, it's all
Make money.
for money.
So now let's say you have a new COVID. So you want to analyze the M-Pro, its protease. How are you going to analyze the M-Pro? You have the sequence.
yeah,
Let's say now you have
define the sequence,
Okay,
open the NCBI,
uh-huh.
copy the sequence. After this, detect the faction and the location, the sequence.
Then
Then the make the picture 3D for the protein.
so that's a word for that. Make a picture of the 3D protein. That's a word.
Yeah,
Oh,
it's good or not?
yeah, but the keyword, that's a keyword for that.
Yeah.
What do you call that? You made a picture of the protein structure.
Yeah.
That's the one word for that. What do you call that?
I need diagnosis for the effect and for the mutation for the
That's a word to make a structure of that protein.
yeah
What do you call? How do you make a structure of that?
modeling.
Yes! You do a model of
Yeah,
the protein.
model the protein. Yeah.
So now you know the modeling, you know the word model. You model the structure of this new protease. So you don't say make a new picture of this protein. You
No,
say
this modeling.
so you just model it. Then what's next?
Identify the sequence. Open the one tools for the bioinformatic NCBI.
If you don't know, if you write all these, I will give you mark as well.
Okay.
You just write blah blah blah. Even you say make a picture of the new protein, of the mutant protein, I also will give you some mark. But the keyword is model.
Please, Victor, need help.
Modeling.
Not zero.
So the keyword is modeling.
Yeah.
So now you have you have a model of the new,
Okay.
let's say you have a model of the new protease.
Yeah.
What are you going to do next?
Don't know.
Huh? Don't know. So you have the native.
So this question it means how to get to this picture.
Huh? This picture?
Yeah,
No.
this is the model.
No, it's not model.
Oh, this is not the model. This is the real structure, X-ray structure.
The model is characteristic, the structure 3D.
The model is this one is
It's part of one.
this is you have a mutant of this protein. So when I tell you you have a mutant of protease, this glutamine what glutamine 395. So when you hear when you are told 395, you don't know where it is. That's why we do a model, and then we can find out 395
Check
is
this
here.
point by number.
So when you open the structure, you know 395 is here. If you only have the sequence, you know 395 is here, but you don't know how it interact inside the protein. That's why you need the model. You make a model, then you see 395 is here, and it become glutamic acid. Then you know, you can guess what happened. That's why you need modeling. Alright? So it's the same thing.
This is
Number
for
one.
modeling.
This the same. You have a new protease. You have a new protease, so we want to know. You do the model. So what do you want to know from the model? You do a modeling of this new protease because why?
Need find the structure.
Structure, yes. Okay,
Yeah.
now you know the structure.
Yeah.
Why you want to know the structure?
The structure I need check for the location for mutation.
Yes.
And, something.
You want to look at the mutations.
Yeah.
For the new mutant, right? The new mutant, the protease, it has some, the mutant protease, definitely it will have some mutations. If it does not have any mutation, then it will become the native, is the native. So when you have the new mutant, it have new mutations, you want to compare, you want to see the mutations. How to see the mutations? I mean, like, once you have the model, you know.
Modeling for structure protein.
So you look at
can-
the location of the mutations, right? And from that, you can, now you know the location of the mutants, location of the mutations, What can you conclude? What can you tell?
Until after the you can check, I tell the this area have the mutation. After the modeling for the
Yes.
structure, detect the area have mutation. After this you can write this area number area, this find or mutation, this find mutation.
Ah, so let's say you have mutation in this area.
Yeah.
What can you tell?
I
What can
think-
you? Where can you? What conclusion can you make about this mutation?
This area have the they have the new mutation. Because I think because the effective mutation you can effective the viral.
So the way you write, I mean like, in that sense, you okay when you do the model,
Yeah.
which part you want to look at first?
Location, function, design, mutation.
No. I mean, for this mutant, after you made a model for this mutant protease, you made a model, right? So you open, you use PyMo, you open, you look at the structure. Which part do you want to look at first? Which part of the structure you want to look at? The first,
Oxygen and
no, come, I can draw. All right.
this out or active active seed.
Yes.
Active seed.
You see, you have the
can
model.
check the mutation, the location of the mutation outside the
Yes.
protein or inside the
Yes. That's you need to write it down, right? So when the exam you cannot just keep saying you look at the location of the mutation, blah blah blah. You have to see straight away. You say you check the active site and see any mutation or not, right? You compare the active site. You have to compare. It's not just look. You compare. If there are mutation in the active site, what happened? Then you have to see lah. If there are mutation in the active site, what to do next?
I can detect the number of the mutation and the effective in area.
So how do you write?
I don't know.
Can you understand? You have to understand why we want to do models, why we want to do modeling. So now you already know how to do modeling, right? From what Dr. Chu,
Yeah.
you know the step all doing the modeling. Okay, now you get the models. Next, how are you going to analyze it? So I take as enzyme as an example. So of course, the mutase, the protease, immediately you look at the active site. Then if you see there's one mutation, what are you going to tell about that mutation? You have to
effective the mutation.
What is the time now? I thought we can finish within 1 hour, but
Yeah.
it's until 4 o'clock, right? 2 until 4, right? Okay, we still have time. My mouth is not very good.
What?
Just the protein is poor. This is just now I talk about the
A mutation?
all like just now the amylase and protease, they are enzymes that cleave polymers. Okay. Okay.
Polymer. What is polymer?
Polymer. You know polymer? Monomer, dimer, tetramer, polymer.
Oh.
Okay. How do you read this one? Polymer. Okay. Then you know monomer. You know monomer. Monomer is 1, polymer.
Sure, I think you have too much question now. First one, the modeling, and
Okay.
this first one found now too much question.
Only 2 questions.
What the question? This
Only
is a
2
question, and this is a question, and this 3 question.
Oh, now we are looking at the C. C actually is very simple. Come,
C is not important.
simple, not.
Important or not important?
It will give you marks, so it's important.
No. Please, doctor.
Huh?
This is C important or not?
Why?
This C important or not important?
I am telling you how to answer this question. I cannot tell you what questions are coming up.
No. I ask you, this is important or not?
Everything is important.
Oh. No, Victor, please.
You know polymer already, huh? So enzyme have the catalytic side. Huh?
Mm-hmm.
So polymer means in amylase, it cleave starch. Starch is a polymer of
Yeah.
a polymer of what?
Glucose.
Yes.
Glucose.
Okay, glucose. You have glucose. Okay. Now we are talking about protease. Protease is cleaving other proteins, and protein is a polymer of what? Protein actually is a polymer.
Amino
right?
acid.
Yes, amino acid. So you have amino acid. Huh? So for protease, some protease, you will recognize 6 amino acid, and then you will cleave in the middle of them. So you will name it lah, P1, P2, P3 lah, P1 dash, P2 dash, P3 dash. This is what we call subsite. The whole thing is called the active site. Active site. Inside the active site, we have subsite. Subsite, you know, subsite. Subsite.
Yeah, you have.
Subsite. So this is the active site of subsite. 1, 2, 3, 4, 5, 6, amino acid. Okay. Now we talk about protease. This is very short. Okay. This is COVID, because COVID is very important. Everyone study it. Everyone crystallize the structure, the complex. And if you go and Google the PDB, there are more than 1,000 structures already. So we already know how N-Pro, the protease, how it binds other proteins and cleave it. So this, the blue one is the enzyme. The pink one is the sequence of another enzyme that the COVID, the protease will cleave. Okay? So of course, when you have a model, when you have a mutations, you want to look whether the mutation is inside the active site or not. If it is inside the active site, what do you want to look at? We want to look where it is. Okay? Let's say it's the same like just now the glutamine and glutamic acid. We want to see whether the mutation will affect the binding and the cleaving of these proteins or of these substrate or not. For example, what should I take? This is not very good example. This is right. Let's say this one, I don't know. Let's say this is another aspartic acid. Let's say this is aspartic acid. It is mutated to alanine. So alanine and aspartic acid, amino acid. Acid. Why drop? So the other lectures you can understand, right? The
Yeah.
other lectures, all the lectures you can understand, huh?
Yeah, something.
Only my lecture you cannot understand.
I'm don't like chemical.
You don't like chemical.
Yeah, yeah. But all student, this part is very difficult for you.
The
You corrected for the student. Any student take the full marks.
I mean, some they answer very well. Some they can understand.
Which student?
I cannot remember the name. I can't even remember your names. You don't expect. When you write, I know you. I guess it's you. Your writing is very difficult to read. Is
For
it
me?
you or
No,
you?
For Gao.
Or maybe you are.
Yeah, yeah.
What?
Your
For writing is very difficult, yeah.
Your writing. Let me
Right.
see.
This for me. No, no, I'm writing is good.
Can you write something and show me? You see, my name is blah blah blah. I'm from China. I cannot. That's one person really.
This, he. This for my right.
It's difficult.
Difficult for Gao. I think.
what?
That's one.
Well,
Really,
Identity?
I cannot read.
Identity?
Take 0 for difficult not read.
Let's see, just like I say, like let's say aspartate and glutamate acid, you can see, this is longer. This is longer. This is shorter. This is only one C, but this is 1, 2. Can you compare the NH? Shoot. Just one here. This one shoot. 2 C.
3.
So it's longer. Okay. So sometimes
Glutamic acid 3. Aspartic acid 2.
So sometimes when we look at the structure, we want to see the mutation. Let's say this one is just now asparagine is 1C. When it becomes 2C, it will go up. Let's say this is 1C. It becomes 2C, go up. When it go up, it will clash with this one already. So it will affect the binding. Okay? But let's say if it is this thing, if it is mutated to alanine. Do you know the smallest amino acid? Actually, the smallest amino acid is glycine.
Smaller.
That's glycine. Glycine is nothing.
Smallest.
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 The smallest. Alanine is the second. Alanine, then you have 1C.
Oh.
That is 1C. Alanine. Then aspartic acid is 1C plus 1COO. Okay? So alanine is smaller. Alright? Okay. Alanine is smaller. Then when we come back, this one. So just now, this is the aspartic asparagine. If it becomes glutamine, it will become bigger, extra C. It will clash. But if this one becomes alanine, it will become shorter. Then it won't clash, but you will lose one hydrogen bond. This hydrogen bond will disappear because it's smaller, much shorter. But you still have other interaction. So the whole thing still can go inside. Maybe the activity is lower, affinity is lower, but it still can go inside. Alright? So sometimes we want to look at the type of mutation. Mutation become bigger, this one cannot go inside, then maybe it will affect the binding. But if it becomes smaller, it still can go inside, but the affinity may decrease. But it still can function. Okay, so how do you
So we're using yeah, like the anim 已知的啊，sorry，
so
noise. We're using the noise structure to combine with the
noise
some
structure.
side. Yeah.
we
Some
have
side.
so now you have the mutant,
Yeah.
you have the native structure. Two of them you have to what that is one word for them, you have to
Combine. If they can combine the
this is not combined, we call
Not combine.
superimpose.
superimpose.
Overlay, I mean like you superimpose them together. Superimpose, I mean like we
Impose. Okay, I know. 实讲可能这么说。
I'm hungry already.
Oh, sorry.
You are hungry?
Really?
Me, I need to sleep something
You are
because
sleepy.
You don't have enough?
because I'm not asleep because I shoot the game.
You play games?
Yeah, no,
Yeah.
I'm shooting a game. My country with the other country.
Oh, you mean football?
Yeah.
Soccer?
Yeah,
So you stay up to watch?
yeah. Because the change time different between my country and Malaysia 5 hours.
You are from
I'm from Iraq. Al
Iraq.
Yeah.
Okay.
Sumerian. You know Sumerian?
Mali.
Iraq?
Yeah.
Mali.
I know Iraq.
No. Sumerian people, Babylonian. You know this history?
Iraq, I know.
No,
Iraq.
Iraq. Arabic country.
Arabic country, yes.
Yeah.
Iran not good.
But
They are
yeah.
fighting.
Yeah. But you know some history for my
The
country.
history.
Yeah. The Sumerian, Babylonian, Ur, Ziggurat, something.
Lots,
Yeah.
huh?
What is Somali city?
No, Sumerian, this old people live in my country, live in this area. Same the Egypt.
Egypt, yes.
Yeah.
Now you know Palestine, everyone knows that.
Oh.
Because Palestine, Israel.
Yeah.
And then you have the what? Iraq, Iran, India, Lebanon.
Yeah. I shoot some people for live in Malaysia, now visit in my country. Too much people.
Okay.
Yeah, tourism and something.
I went to, I went, but not Iraq. I never go to Iraq before. I went to Syria before and Jordan.
Ah,
There.
yeah. It's good.
Syria, Jordan.
In my country, is very old history. The first one people make the writing. First one make agriculture, make everything in my country because the first people, the Sumerian and Babylonian, Keldan, Jewish, something, all this.
All together.
Yeah, but now not find all this. Only Sumerian people. You know marshland?
Masha?
Marshland, Al-Ahwar. This natural area. The Sumerian area is natural area found in
Iraq.
in Iraq. Found the some plant and some buffalo, some cows. All of this fishing,
You're from
fishermen.
there.
I'm working in the NGO. The NGO support for this area.
Alright.
Yeah.
Very nice.
Yeah. I like work in the environmental. Already I'm working environmental.
Then why do you want to take modeling?
First one, I talk with the inform. I need make my research with the poison, snake poison.
Snake poison.
Yeah, my idea. First one talk with the Dr. Gorjit my idea. I live in the some area. The climate change effect in the area. The some snake development the something make the poison. The first one, this snake is not have poison.
No poison. Suddenly they become
Yeah.
poisonous.
Why have poison now? Because development, because the effect the climate change, because make some mutation. I think this not natural poison. I think this viral, bacteria, something, deployment. Yeah, this my idea first one. But I first studied one semester, or this not find any info.
It's difficult.
Yeah,
It's not easy.
yeah.
And
But-
why?
But me, I like work environmental.
Yeah, it's good lah.
I'm already work in hospital.
Mm-hmm.
Yeah, but in hospital only license the human license. Now the molecular license. This difficult. This different.
The gap.
I'm work with the blood, with the urine, with the something. Already I'm work in microscope. It's very professional. Yeah.
Yeah, as long as you like your job. So after you graduate, you go back to the NGO as well.
I'm already now work with the NGO by online.
So you continue working there lah after you graduate.
Yeah.
Ah, okay, good, good. And then why do you want to come and study?
Just
Well-
job.
Job you. So before you came, did you work in China before you came?
A little.
A little. What did you work as?
Examination.
Examination. So it's not related to biology.
But my work, I have a private lab.
Mm-hmm.
Yeah, in my country, you can open the private lab. Have the private lab.
Private lab.
Yeah.
You have your own lab
Yeah,
doing research.
yeah.
Oh.
No research. They make the analysis for patient.
Ah.
Yeah, I have the full automated machine.
Full
Oh,
automated
yeah,
machine.
yeah. Now I see the ELISA in Inform is very old. Now found the ELISA full automated. You can take the sample, wait the 10 minutes. You can.
See everything, huh?
Yeah.
Very, very simple now.
Yeah.
Very.
I have the report R1 machine. Is very large. This machine you can make 300 analysis when.
Very fast, huh?
Yeah, it's very fast.
High throughput, lah.
Yeah, but now it's very it's different. It's difficult. Yeah, the private lab is very good job.
Okay.
Yeah, money and you can make a private lab. I asked him that some people in Malaysia why not make the private lab. Ask me, tell me is difficult because they make the bare machine and difficult with the government. Yeah, you make hospital, you can open a private lab.
Are you married? Do you have a?
No.
Not yet, lah. Okay,
No.
still young.
Yeah.
You already married?
Married? What married?
Married. You already have a
Yeah,
wife,
ring.
children.
You married? You have family, married?
You have a
Husband?
wife. You have a baby,
No.
children.
No.
Not yet.
No.
Single.
Single? You single?
Girlfriend.
You have girlfriend?
Wife.
Wife?
No. Not
Single.
yet lah. Okay, say.
You single?
Yeah.
You single?
Yeah.
No. I'm married.
Do you have child?
Yeah, two.
Good luck.
Alright, so superimpose. Superimpose, you can see, green and red one, you just overlay them. And then you can compare. That's what we call superimpose. Okay?
So
So
we how to answer?
so now you can answer
Yeah,
the question.
already
Yeah.
first one.
Oh, I know.
Alright? Yeah. So when you superimpose, you can see this one is shorter or become longer, for example, and then you will tell lah. Then so input the characteristic of this mutant. Alright. Maybe that is a bit universal.
Victor, this is not important, please. This important or not? This important, the characteristic only this with this question. Two questions.
We only need the most important one.
Please, Victor, don't have time on this Victor. This question is important.
Yeah.
And this question I just
Yeah.
only two question is done.
Yeah.
this question and this question. This is important or not, please?
Choose something.
Please, Doctor.
I can tell you, question A is not important. That's all.
I know.
Okay, I tell you, you don't need to know whether it's important or not. Because for B, you already know the answer, right?
Yeah.
So whether it's important or not, it doesn't matter. If I tell you it's not important, you already know the answer. Now I'm telling you the answer for C. Whether it's important or not, you just remember the answer.
Because you asked two questions.
Time. I need more information.
Then you remember the answer.
Not good.
Okay, come. So what will happen is, let's say, this is giving, okay? Let's say it binds here. Now let's say it mutated, it becomes something bigger. When it becomes something bigger, it will block here. So this cannot go inside of. So we can say, alright. I mean now it's the second of the characteristic of this mutant. The thing is, if this is become bigger, you can say that the mutation, this mutation, it become bigger, then it affect the binding of this sequence.
Yeah.
Okay. Then we know for protease, usually protease, they will recognize a sequence. The sequence it means, like, for example, like here, only small amino acid can come in. It's not like any amino acid can come here.
Yeah.
Other bigger one maybe cannot come in. So for the native, it recognize one sequence, one motif, one sequence. Okay. Let me show. This one just now. What I say is the SARS virus protein, it has one RNA. So it synthesized one big long protein. The protein is very long. 16 proteins, the polyproteins, very long. And then inside there's one protein, is protease. I guess this one. And then this protease will cut. So cut them into individual proteins and they will function. This is for virus. Virus usually they will produce one polyprotein, a very big protein. Then they will cleave. You see, all the protein inside the COVID is already know all the structures.
Yeah.
Alright. The mechanism you don't have to. This one you don't need to read. This one, I won't. It's not showing me. I didn't put here. Oh, 4 o'clock. So you see here?
Yeah.
So the protease actually it plays between. You see how many? This vitamin and then the leaf here What do you see, right? So okay. Standing around. So it leaf here. Alright. So when you see based on the mutation, what you can guess, what you can guess is whether whether the enzyme still can recognize this sequence or not. Maybe it cannot recognize this sequence, can recognize different sequence. For example, if this is bigger, this is bigger, then this thing cannot go inside, but maybe shorter one can go inside. So based on the mutations, we still can predict the new sequence for the ligand. We can predict whether it recognize the same sequence or it recognize a different sequence based on the model lah. Then
Because they have the same function area relation.
because for example if here there's no mutation,
Yeah.
then it will bind the same thing.
Yeah,
This one you don't need any change. But if this is bigger only here,
yeah. Only
then this
here
one will
mutation.
change.
Yeah,
But the other will not change.
yeah.
So we can just say like that. I mean, like based on the mutations, we can speculate lah whether it still recognize the same sequence or a different sequence. All right.
Oh, okay. Don't worry.
So many things. All right.
We don't combine because it's
Combine.
yeah.
I mean, if this is bigger, then this will have to become shorter. I mean, this big you
Yeah.
cannot go inside, but small one.
We can do this.
So if it's shorter, let's say, or it's alanine, maybe the sequence still can go inside lah. So it recognize alanine, for example, here. In this subsite, it recognize alanine. Other subsite, they still recognize the same thing, the same amino acid except this. This one maybe is alanine or something shorter, cannot be long. If this is mutated, one example, so we can.
We're not recognized by the not combine.
Combine.
I don't know how to recognize like the if the
If structure-
structure in this.
It's not recognized. It still can go inside, can bind, but maybe there's no interaction. Or maybe this is hydrophobic, then hydrophobic interaction. Like you see some of the amino acid like this one is hydrophobic. There's no interaction, but still it can go inside. Because here is all hydrophobic, and this is also hydrophobic, then it can go inside. Or maybe like this one is something big, but then this serine becomes serine here. Maybe still can form hydrogen bond with the new mutated one, mutated amino acid here. Maybe this serine, maybe it still can form hydrogen bond. We don't know lah, but we can predict. I mean, in the sense we can predict lah the new binding sequence lah. Predict. We can predict.
Product, yeah, third.
Predicts.
Yeah.
Do you know in Chinese it's called what?
期待
You can predict because modeling is you predict the structures, right? Modeling is predicting the structures. You can predict the structures. So in that sense is, for example, I draw again. So this is the the active site. So we know something can bind like this one. If there's mutation, it mutated become like this. Then we can predict, the ligand is like this.
This mutation?
Let's say a mutation when it is square is like this one. Then there's a mutation make it like this one. Then we can predict the ligand. You know, this is so like this one we know this cannot bind here already, but something like this one can bind. This is the question for the answer for
so this is I mean we can what
Okay,
so we can predict the shape. I mean we can predict the new catalytic site, and from the catalytic site we can predict whether we can predict the new sequence, the new substrate.
So what I mean before it's we use this is no protein amino acid and we combine with the mutation part
Yes, because
we use this combine to recognize the mutation because it's different. Yeah, I mean this. Yeah, it's right.
I mean, like let's say this side is still the same, but this is different.
Yeah.
So we can predict.
Yeah.
We can predict how. We can predict the 3D sequence.
It's a predict,
Predict.
but predict not the future.
Future.
Yeah,
You-
future.
Future.
I think predict is future, not future.
Predict. You have to search again.
Yeah, I know.
I don't predict.
Structure prediction. You can put protein structure prediction. What's in Chinese? Protein structure prediction is. What is homology? Homology modeling. What is modeling? Actually, modeling is prediction. You predict the structure. It's not the real one because you don't know. If you want to know the real structure, you have to do MNR and X-ray. Modeling is just prediction. You predict the structure.
Yes, this you mean that's mutation just a prediction structure.
Yes. You predict the active site, and then you predict what can bind.
Yeah. Oh no.
Okay. So now you know the shape of the catalytic site. Then you can predict what can bind inside. Okay.
So
then,
you just imagine.
imagine. Of course, you cannot. You cannot write a lot of things,
I know.
right? Then let's say, now the thing is, okay. Now you can predict this shape already.
Yeah.
Okay. You predict this shape. Originally, the native one is this one. Let's say this is native. Then this is the
Predicted this
mutant.
because effect mutation.
This is the mutant.
Yeah.
Then from the mutant, so you know this shape. How can you use this information?
Use this information.
How to use this information?
Why we need use this information?
Then why do you want to do modeling?
I need full. I
Uh,
need only done exam data.
Find out how the information can be utilized. How can you use this information? Always remember, like, why do you want to do modeling? It's not for fun, right? It's not like because
So I want
academic.
to use it to combine with like the prediction structure. Yeah.
No. You predict already. You already predict the mutant. Okay?
Yeah, I know.
This is the native.
This
Alright?
mutant is I predict.
You
Yeah.
predict this one already. So from this, you can predict the substrate, right? What
Yeah.
else you can predict?
Yeah.
What else you can use? You know the shape of the protein. Next, what? You know the shape already, so you predict the shape of the substrate. What else you can do? This is the question I ask you. The first question.
Okay.
The first question I asked: why do we do modeling?
Yeah, need fiction, need engineer design, need drug. Okay.
So this thing, what can you do with this new structure?
Yeah.
I mean like, the new COVID coming out with the new mutation in the protease. So from this structure, you predict this structure already. How can you use this structure? You don't predict it for fun, right? It's not like, oh, you predict this
Combine
structure,
with the no protein. Yeah.
combine with other.
No. The non-protein not.
Then
Yeah.
yes,
If
you
if it is a drug, then
yes, you can design new drugs, right? So how to use this information? You know this shape.
Need
Yeah.
information, the new mutation.
You can predict first the drug that bind to this native still can bind this or not, right? If it cannot bind already, what can you do? Design new drugs, right? This is why we do modeling. Always remember why we do modeling. It's not because we want to take
When you make
examination.
any drug,
You don't do modeling for examinations, because my supervisor asked me to do modeling, so I do modeling. No, we do modeling because we want to use the information. How do you use the information? The function. Now you know how it binds. Then, because this is a pathogen, it's a dangerous protein, a dangerous virus. So we want to produce drug, design drug. How you can design new drug? If
I see.
so you do,
I presume.
okay.
This is the
Native.
this one. This one is the COVID virus.
COVID virus.
Oh, yeah.
Okay.
This COVID virus, and we predict and we have we have a structure like this one. Yeah.
Okay.
Like this one.
Yeah. This X that from the
Oh,
X-ray
we
structure.
don't have a structure. Oh, we have prediction structure. Yeah.
This actually is the X-ray. The native one is this one. This one is X-ray. X-ray structure. So because the X-ray structure, the known structure, the real structure, we can predict the mutant using this known structure.
What's it? X-ray.
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 Do you know how we solve structure? How we determine structure? X-ray.
Or X-ray.
X-ray crystallography. X-ray crystallography to solve the structure, or we can use MNR. NMR also a way for determining X-ray crystallography or NMR is used to determine the structure of protein. Now we are doing the modeling. Modeling is not accurate. It's not accurate. Accurate,
I need structure, I need fraction, I need something I need make the drug.
Yes. So now you understand already why we do modeling.
Yeah.
Usually always is you want to for this, of course, we are not going to do protein engineering because it's virus. We cannot mutate the virus. What we can do is drug design. We can design drug. We can predict its function. We can design drug. So this is the known one. From the known structure, we can predict whether it still can bind. The most important thing is we want to know our drug. We have some drugs already for the native. So we want to know the native drug still can inhibit this mutant protease or not. Okay?
Okay, Doctor, you Hungary.
Inhibits in drugs. What is the function? How to
Vaccine drug inhibit the virus, inhibit the infection, inhibitor the infection. Some people do have fever. Take the people the paracetamol, inhibit the fever.
yes.
Yeah.
I just want to ask if we have had this and we,
The native, yes. Native. No native? Native is the
why
native and mutant.
we need the new structure of the protein?
Native and mutant. Okay? You know?
Yeah, I know.
Mutant
But we just we have had this. Why we need the new structure of the mutants?
mutant because we want to know for protease. Suddenly the protease the virus become very dangerous. We want to see whether we have a drug.
We
Mutation.
we can say this is a new virus. Yeah.
Not new virus. New
mutation.
the COVID mutate. Let's say the COVID mutate.
New virus.
Then let's say we have a drug. This is the drug.
This is the
Can
this is virus. This is no. This is called COVID.
No, this is COVID.
Yeah.
This is COVID.
This COVID.
Let's say
This
this,
is
this,
the
is
new
COVID
mutation.
mutant.
this COVID 2 and then this is COVID 3. Next year
Oh.
COVID 3 coming up.
Yeah.
And then our drug, this drug, can this drug still bind here or
I
not?
think the mutant
Yeah, not
is a new virus. Yeah, it's just a new virus.
New
this
strain,
is
new
still in
strain.
here. A new mutation need a drug still in here.
New
So
strain.
so.
Ah,
Oh, this virus mutated to this,
mutate to this.
and we need a new the
A new
production
drug, a
production
new
drug.
protection. Yeah.
Maybe.
Prediction drug.
Maybe we need
yeah,
new.
yeah,
Or maybe
yeah.
this still can okay. But if
I
you
just-
add this one,
I
you
just
no
explain
longer.
the two pictures.
Yeah.
This picture is mean this.
So now you understand? Huh?
Yeah.
Thank you, Doctor.
It's not that difficult, right?
Yeah.
Hopefully you can pass your exam next week.
Inshallah.
We still have two.
Doctor, please, I need pass because I need from my country. My father have the heart disease.
Okay.
I'm not sick.
You want to go back and get married as well?
My father need make the surgery for the heart.
Alright.
Make the
Surgery.
yeah
bypass.
some vertebrae stop.
It get clogged, blocked.
Yeah.
So you have to bypass, do the bypass.
Yeah.
Your father.
Yeah, now call me, wait me, Ra'ad. Anytime done, your exam coming.
Okay, so you have to go back soon.
Yeah.
Okay.
Or after the exam, then you have
After
to go
exam,
back
yeah.
next week. Okay.
Yeah.
Wish your father.
So
all
we
the
can
best.
continue.
Huh? Continue.
Yeah.
Have you finished already?
Finish?
Yeah.
Really?
What else you want to know?
特征.
So you know all the things already, lah.
So what is the mutant
So
characteristics?
Characteristic.
Yeah.
so whether it still can bind the same amino acid or it bind different amino acid.
This general character.
It's the same thing. It bind the same amino acid or different amino acid. Then if it bind to the different amino acid, it means the subside become triangle.
Of course.
Then you design new drugs. You can use the information.
That's I said before.
Okay, yeah? So
Uh,
once you have the mutant, of course what you do?
Yeah.
Just do modeling first, right?
Yeah.
Once you do model, you have to compare them. Compare with
Yeah.
the native.
Engineering, drug.
Yeah.
Why need the modeling?
So how to use
Yes.
the last one?
How to use the information.
Yeah.
You have a new subside, become triangle. So you know the subside you know the active site is mutated. So how can you use this information?
I don't know.
You can use this information to design new drug.
Yeah.
Ah.
A new mutation, a new drug, need new drug.
This answer?
Yeah.
Really?
The COVID already find a new COVID. This mean a new mutation.
Yeah.
A new mutation.
Yeah.
You know, some company Pfizer and the other company make a new
Drugs.
a new drugs. Why need new drugs? Because this find a new mutation.
It's not you just know the new structure then finish.
Yeah.
It's not for fun. You
Use
don't.
this to design
don't
a
do-
new drug is the information to use.
Yeah. If without this modeling, you cannot design new drug.
Yeah.
How to design new drug?
Yeah. Do not have formation.
How can you design new
Not
drug?
find engineering,
So,
not find infection, not
The
find.
answer just the one sentence.
Pardon?
So the answer is just the only sentence. Really? it's to design a new drug. Is answer. Yeah. Point out about the information can be.
Whether the old drugs still can use or not, you can know. If the old drugs for the native, if cannot, then you have to mutate. You have to design the new drugs.
Yeah. Okay. One sentence.
The next week, I mean, it's not totally the same question, next week.
Okay.
It's not totally the same.
Okay.
I cannot use the same question. I will change.
In all this, you
I
can
change a little bit, but more or less the same. I mean, like the idea is there lah. Why you want to do modeling lah? Always thinks about like, you want to know the function, then you want to know the, you can do an enzyme engineering,
Yeah.
and design drugs.
This.
Don't know, just write all these things.
Thank you.
Okay.
You already two question.
I just give, I mean, A and B only lah. My question will be 5A, 5B, no more C. Okay?
Please, during the correct for my.
So the first question is the yeah.
I send you. But how much take me money? Because yeah, we need a question. How much money?